Prakash. I am going to discuss about waveform of action potential. What is resting potential? Whenever there is a passage of impulse involved in the nerve cells or muscle cell, the electric potential ranges between -60 to -95 millivolt, which is known as resting potential. The change of resting potential when the passage of impulse is involved in the muscle cell or nerve cell is known as action potential. This is the waveform of the action potential. The -70 denotes the resting potential and the +40 denotes the action potential. How the change occurs from -70 to +40? Yeah, the cells of the body are surrounded by body fluids which consist of ions. The primary ions are sodium and potassium. Inside the cell there are less number of sodium and more potassium. Outside the cell, that is in the body fluids, there are less potassium and more sodium. In between the body fluids and inside the cell, there is a semi-permeable membrane which consists of voltage gated channels and potassium gated channels. Whenever the nerve cells detects the impulse, that is a hand scrolling in our hand, it will make a stimulus which will reach the potential to the threshold. If it doesn't reach the potential to the threshold, it is known as failed initiation. If the potential is reached to the threshold, it will cause the voltage gated channels to open and sodium ions will flow from body fluids to the inside the cell. So it makes the potential inside the cell more positive and increases the potential to +40. Once the potential is reached to +40, that's the action potential, it causes the potassium gated channels to open and close the sodium gated channels. When the potassium gated channels opens, all the potassium inside the cell will reach out and it will makes the inside the cell more negatively charged. So the potential decreases to the resting potential. Not even resting potential, even more negative than the resting potential, because to the certain limit the potential will continuously move from inside of the cell to the outside of the cell. So it will cause more negative potential than the resting potential. After this process, through the ATP or energy cell, sodium and potassium will reach their default position and it will makes the potential to reach the default resting potential. The terms used in waveform of action potential, namely hypopolarization. It is the initial increase of membrane potential to the value of threshold. Once the increase is not reaching the threshold value, then there is no action potential will happen. Next, depolarization. The threshold potential opens the voltage gated sodium channels and causes large influx of sodium ions, which increases the positive charge inside the cell and it will cause the positive electric potential. Next, repolarization. The overshoot of the cell potential opens voltage gated potassium channels which cause potassium efflux, decreasing the cell's electropositivity. That is, whenever the positively charged potassium leaves the cell, the positive charge is decreasing and so there is more negatively charged inside the cell, which will cause the potential to decrease, which is known as repolarization. Next, hyperpolarization or refractory period. The repolarization stage will always reach to hyperpolarization, not to the resting potential, because to the certain extent the potassium gated channels will open. So it will lead to the hyperpolarization state. The hyperpolarization means a state in which the membrane potential is more negative than the default membrane potential. In the waveform we can see that the default potential is -70, but in hyperpolarization it is even more negative. Next, the refractory period is time often after an action potential is generated, during which the excitable cell cannot, that is what it means it, whenever a impulse reaches the action potential, no other impulse can reach the action potential at the same time. No other cell can produce the action potential at the same time. So there are two types in refractory period. One is absolute refractoriness, another is relative refractoriness. The absolute refractoriness is completely same. That is a period of time which a cell cannot respond to any new stimulus. It's same as refractory period. But what is relative refractoriness? In relative refractoriness, the action potential can be triggered for the new stimulus, but the stronger stimulation is required. Only when the stronger stimulation is happen, then only the action potential can be triggered in relative refractoriness. This is the waveform of action potential. This is for nerve cell, and these are the action potentials for skeleton muscle and cardiac muscle cells. Thank you.